This tutorial is about segmentation editing in the Baxter algorithms. Here I have selected 3 image sequences where I will perform segmentation editing. I'll open the manual correction user interface and select the tracking version that I want to process. Let's say that I want to edit the outline of this yellow cell. Then I select the segmentation editing tool. This drop-down menu has a number of options for this tool, but for now I'm just going to use the default options. So first I click on the cell that I want to edit. I left click to draw and add pixels, and I right click to erase pixels. Then I drag a region. When I release the mouse button, the region is updated. I can change the size of the region using the scroll wheel of the mouse button, or by pressing the plus and minus buttons on the keyboard. I erase by using the right mouse button. You can also join false positive regions with tracks in them using the segmentation editing tool. So if I include or draw on both these regions, then the false positive region is incorporated into this cell region. And holes are filled in by default. So this hole disappeared. But you can choose in these menus to allow holes, and in that case the hole will not be filled in. You get a hole in the final region. If you select fill holes, all you need to do is click on the region with a hole in it and the hole will be filled in. If you join regions which have cells in them, you could, for example, join these 2 regions just to show you what happens. Then the segmentation will be redone, and the region is split using k-means clustering, just as segments are split after the track linking. There are other possibilities. I'll have to move this one. If you select merging combine, then the regions will be the biggest region will take over the segment of the small region, and the small region becomes a false positive cell. And then there's a third option, which is overwrite, and in that case the region that you first, I need to separate them first. The region that you first draw on will take over pixels from the second region. If you draw a new region in the background, that region will by default become a false positive object. But you can select to create a true positive object in the menus. And then you create a new cell object in this frame. The same thing happens if you erase to generate multiple objects. Then the fragments will become true positives if you have the create true positive option selected. If you have the create false positive option selected, then the fragment will become a false positive object. Now I'll show you something in the following image sequence. First, I will select the most successful tracking option, the most successful tracking result, and then I will go to a frame where the watershed transform failed to separate two cells correctly. So here's an example of that. Then I just use the segmentation editing tool to separate the two cells, and then this region becomes a false positive region. This false positive region can then be joined with the cell region just by clicking on the boundary between the two cells. There is a line of cells of pixels missing between these two regions, but these pixels are filled in automatically when you click on the boundary. But now I have the overwrite option selected, so I first need to select one of the other two. And then the watershed fragment is merged into the cell region correctly. Now I will go to the 3D dataset to show how 3D segmentation editing works. I open a tracking version, and then I look for a cell that needs to be edited. So here is a cell where I could add this thin region to the segmented cell region. So I zoom in on the cell, and I select the segmentation editing tool. I'm not allowed to perform segmentation editing directly in the maximum intensity projection, because then the program wouldn't know which Z-slice to place the edits in. So I get this error message. I need to deselect the maximum intensity projection, and then I can go to the desired slice either by moving on the slider here or by using the zoom tool and holding shift down when I click on the Z-slice that I want. I could actually start here, and then I'll just draw just as in the 2D segmentation editing. The shape of the brush is a disc, so it's a circle or a circular disc in the XY view and a single pixel plane in the other two views. And I can go to the next Z-slice. Oh, sorry, it was the... I moved too far. This is the next Z-slice. And then the final Z-slice. Now I've changed the segmentation of this object. Now I'm zooming out and I'm looking at the maximum intensity projection again. I can choose between having a disc-shaped brush and a ball-shaped brush. If I select the ball-shaped brush and I want to place a ball somewhere here, then I just select a brush size that I want, and then I can click to generate the ball. I can also drag to get a bigger region. If I'm editing using the disc-shaped brush and I create a new region like this, then I can go to the next Z-slice and just draw on top of it, and the two regions will be joined into a single volume. As long as I click on top of the other region. And if I'm using the disk-shaped object, I can do the same thing in all 3D views. It doesn't matter that I'm in the X projection or the YZ view here. The disk becomes a circular disk in this view and a single plane in the other views. And I can do the editing just in the same way and build a volume through the X slices instead of the Z slices. So this is everything I'm going to show in the 3D view. And now I'll go back to the 2D view to show that you can create objects even without having a tracking result. I can just start drawing, and in this case it's gonna be like performing the segmentation completely manually. That can be useful if you want ground truth segmentation for some purpose, or if you just haven't found a segmentation algorithm that can segment your particular cell type or imaging condition. So I'll just do one cell here and save it. As manual segmentation. And now this tracking version appears here.